right, so this is kind of a little bit of a review, but we're gonna play with it a little bit. How many of you, if I have this number, let's say I have 4, and there's a teeny little baby 2 up in the corner of the 4. What does that mean in English? Kessler, what does that mean?
Squared.
It means squared. How else do we say that?
4 squared.
Not 4 squared,
Second
not
power.
to the second power. Okay, so 4 to the second power, 4 squared. Mathematically, what am I doing? What am I doing, Cora?
Doing 4 times 4.
I'm doing what? But there's a 2.
It's like, wait a second. It's timesing by itself 2 times.
It's timesing by itself. You thought maybe you were wrong. No, you need to trust yourself. I'm going to do that. So it's 4 times 4. How many times?
2.
2. So we have the 4 twice. So what does that equal?
16.
16. Be careful. I have a lot of kids who will tell me that 4 squared equals 8. What are they doing here? Well, it's addition. What do they see? They see the 4 and they see the 2. They know we're multiplying. 4 times 2 is what?
8.
Is 4 squared 8?
No.
No. Squaring is not multiplying by the number. It's multiplying by itself twice. So can we do that with other numbers? Give me a number.
8. 12.
8. We have 8 squared. That equals 8 times 8, which is what?
16.
64.
Oh, right. You should also do.
Who said 16? Okay, so that means you know you need to watch yourself because your brain says, oh, there's an 8, there's a 2. I know what 8 times 2 is. 8 times 2 is 16. That's easy. You have to just, your brain needs to say, no. We're not timesing it by 2. We're timesing it by itself. How many times? 2. So why do we call it squaring it? What does the square have to do with all this? Kessler.
When you graph, don't you change it into a square? Wait, actually, no. I don't know.
Isaac, help him out. He's super close.
So, it's like you're trying to find the area of a square that's got 4 on one side, 4 on one side. It's just 4 and
Well, we can arrange them 4, 1, 2, 3, 4 by 4, and it actually makes what shape?
a square.
It makes a square. That's what you were. I knew you knew it. You were just having trouble getting it out of your mouth. Like if I have over here, who knows? I'm gonna come over and just run camera.
100.
Hi. Who knows how much this is? How much is on here? 10. This is 10. This is 10 times 10, and how is it arranged?
100.
In a square. And how much is it, Kessler?
100.
Kessler's super excited. 10 times 10. So here I have 10 little squares. How many times is it multiplied by itself?
1.
This is 10 to the first power, so this is just 10. And then we have 10 times 10, so that's 10 squared, and it makes a square. What if I want to multiply it by itself a third time?
It's like volume or something. I can't remember.
What do I get?
A cube.
A cube. We get a cube.
Oh, it's called cube.
That's why it's called cubing. So if I have, I'm going to erase my beautiful little square here. So if I have 10 to the third power, how many times am I multiplying 10 by itself?
3 times.
3. How do you know?
Because of the third.
Because of the third power. So 10 times 10 times 10. So what's 10 times 10?
100.
100. And 100 times 10 is?
1,000.
1,000. So this is 1,000. So if this was actually filled with little cubes, which it is not, it's hollow, but we're going to pretend. How many little tiny cubes would I have here?
1,000.
I'd have 1,000 little tiny cubes. So it's 10 times 10 times 10. That's a lot of little tiny cubes. Okay? So it gets very, very big, very, very fast. Can we do this with other numbers?
Yes.
Yes, we can do this with other numbers. Give me a number.
12.
Let's do 4 again. Should we do 4 again? Actually, I said give me a number and then I tossed it out the window. Sorry, guys. 4 cubed is 4 times itself. How many times?
3 times.
So we have 4 times 4 times 4. Well, what's 4 times 4?
16.
Times 4 is?
Wait.
Travis, you literally have a calculator right in front of you. Pick it up and use it. know what it is. Bristol, what is it?
20.
No, it is
No.
not.
Sorry, never mind.
Oh, you know what she did? She did 16 plus 4 and got 20. Watch your.
Oh, it's 24. No, it's not.
No,
It's
16 times 4.
16 times 4 is what, Travis?
64.
It is 64.
Just kidding.
They get big quickly. So, clearly, none of us have our 16 times tables memorized. What do you do if you don't have your times tables like this deeply memorized?
Could get a calculator.
You can use a calculator on this assignment.
Yeah.
You have two choices. You can sit there and do the math. Not this second though, Isaac. Isaac's like, I will go get a calculator. No. You can use a calculator, or you can sit doing the math by hand, or you do have the option to sit in the corner and cry. That is an option. Don't do it.
But then you won't get any Bible bucks.
Then you don't get. I don't pay you for crying. That's the truth. Okay, so can we do math with this stuff?
Yeah.
Okay, we're gonna make a prediction. We're gonna make a prediction without mathing. Okay. What if I have 5 to the third power minus 5 to the second power? What do we think that's gonna be? Predictions. Who can predict? What do you think, Kessler?
5 to the first power?
Kessler thinks it's going to be 5 to the first power, which is 5. Any other predictions?
No. It's just you equal what seeds pendus.
No, we're not mathing it. He made a prediction, now he's mathing it. We're not mathing it. Just, oh, hi, there's a pencil. Should we math it and find out?
Yeah.
Yes. What do you think, Kola? Well, let's do it. So PEMDAS. Kessler brought up PEMDAS because the question is, do we subtract first or do we do the exponents first, right? PEMDAS says parentheses first. Do I have parentheses?
No.
I am off the hook on parentheses. So what do I do next?
Exponents.
Exponents. So what is 5 to the third power?
Wait.
10. Well, not 10.
Not 10. That's 5 times 2. It's also not 15 because that's 5 times 3. So it's
125.
5 times 5 times 5, which, say it again, Isaac,
125.
is 125. Now, what is 5 squared? That's 5 times 5, which is what?
25.
25. What's 125 minus 25? 100. So Kessler's first guess was 5. Because you have a 5 to the third minus 5 to the second, which must be 5 to the first.
No.
Except it is not. It's 100.
Because another times 5 adds so much.
You can't add and subtract. We're going to learn how to multiply and divide numbers in exponential form, but you actually can't add and subtract them like that. It doesn't work. Okay? What if on your first one you have, if you look on the back on your paper, I have it started for you. So what does that problem say? It says 3 squared plus 6 squared. So I have it started out for you. It helps on this. It really helps a lot to show your work and show what you're doing. So what is 3 squared? 9. What's 6 squared? 36. It's right there on your paper.
Oh.
What's 9 plus 36? 45. So on these, it really helps to kind of do it in stages. On your chart, you're going to write it out like we have 10 to the third power, like this. 10 to the third power is 10 times 10 times 10, which is 1,000. You're going to fill in the blanks on what you need, okay?
Wait, we have to write all that on each equation?
Flip it over. Look at the chart. You'll see.
Yeah.
That you have to write. Whatever's missing, you have to fill it in. Okay, so today's just getting comfortable with numbers and exponential forms, mostly just squares and cubes. Tomorrow we move on to bigger. It's okay. All right, so guys, math is a staircase, right?
Bum, 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 bum. That's what I think the staircase would sound like if it was-
So teeny Mrs. Barlow, let's pretend she wants to do math, right? So she's here at the bottom of the staircase, and today is actually the first step on the staircase in our exponents unit. If she does a stair every day, can she do it?
Yes.
If she sits at home and picks her nose for 3 weeks and doesn't do any math and then tries to do the assignment at the end, what will happen to her? She will fall down the stairs and die.
Not die.
She will be dead.
She'll be in the hospital.
She will wish she was dead. Like, she will be sad. So we are going to end up on something pretty, actually this stuff up here can be pretty challenging if you don't come up the stairs. So just come up the stairs with me. We'll be fine. This stuff up here is not that bad. I actually quite much enjoy it. But I am also a math teacher. So I recognize I'm not normal. But,
Do you like teaching?
and I like math. And I really like science. So here we are. Anyway, if you have any questions on this stuff, it's pretty straightforward.
Can I grab calculators?
Yes.